Ever since the timestamp lined up, Atlas hadn't been able to stop staring at one file, Signal 002. Gut feelings are powerful. But gut feelings, Atlas reminded himself, aren't evidence. If he wanted a real answer, he needed real math. Not a guess, not a hunch. An actual, rigorous way to estimate how many others might be out there. Luckily, scientists had been trying to answer exactly that question since 1961. Atlas pulled up a single, famous equation, one he'd promised, back in episode 11, that he'd eventually explain properly. Its name, the Drake equation. He cracked his knuckles and opened a fresh page on the hollow board. Time to do this properly. If the math said you are not alone, that was one thing. But if the math said something stranger, that would need explaining too. Atlas glanced at Signal 002's file, still open in the corner of his screen. Whatever the numbers said, he had a feeling tonight wouldn't end with easy answers. He took a breath, picked up his light pen, and got to work. Time to count the improbable. The story of this equation starts, appropriately, with a conference nobody expected to matter this much. On November 1st, 1961, a young astronomer named Frank Drake organized a small meeting. Location: the National Radio Astronomy Observatory in Green Bank, West Virginia. It was the very first scientific conference ever dedicated to the search for extraterrestrial intelligence. Drake needed an agenda, something to organize the discussion around. So, strapped for time, he sat down and wrote out a simple string of multiplied terms. He never expected it to become one of the most famous formulas in the history of science. One astrobiologist later called it, simply, the best conversation starter ever. Atlas smiled at that description. He liked conversation starters. The equation wasn't meant to give one certain answer. It was meant to organize an uncertain question. What do we actually need to know to guess how many neighbors we might have? Drake broke that question into 7 multiplied pieces. Multiply them all together, he reasoned, and you'd get N, the number of communicating civilizations out there right now. Simple to write, notoriously difficult to actually solve. Atlas copied the equation's skeleton onto his own board, ready to fill in the blanks. Variable 1, R star. The rate new stars are born in the galaxy, on average, each year. A small door opened on Atlas's board, revealing a tiny star being born in a burst of light. Variable 2, F sub p, the fraction of those stars that actually end up with planets. Another door opened, a handful of tiny planets settling into orbit. Variable 3, N sub e, the average number of those planets that could actually support life. A third door revealed one small glowing world, singled out from several duller ones. Variable 4, F sub L, the fraction of those habitable planets where life actually gets started. A tiny spark of green light flickered to life behind the fourth door. Variable 5, F sub I, the fraction where that life evolves into intelligence. A small glowing brain icon flickered on behind door 5. Variable 6, F sub C, the fraction of intelligent civilizations that develop technology detectable across space. Behind door 6, a tiny antenna unfolded and began to hum. And finally, variable 7, L, how long, on average, a civilization keeps broadcasting before it goes quiet. The 7th door creaked open slower than all the rest, and stayed only halfway lit. 7 doors. Multiply what's behind them all, and you get N. Back in 1961, almost none of these numbers were actually known. Drake and his colleagues had to guess, carefully, but honestly, they were guesses. For star formation, they used a modest estimate, about 1 new star per year. For planets, they guessed maybe 20 to 50% of stars would have them. For habitable worlds per system, somewhere between 1 and 5. The biology variables were pure optimism, borrowed from Earth's own success story. Multiply the low estimates together, and you got a minimum of about 20 civilizations. Multiply the high estimates, and the number exploded to 50 million. Atlas stared at the two results side by side. 20 and 50 million. That's not a small disagreement. That's an entire universe of uncertainty, packed into one equation. Since then, real telescopes have actually nailed down some of these numbers. Kepler alone proved that, on average, Every single star hosts at least one planet. R star and F sub p, once wild guesses, are now some of the best measured terms in the whole equation. But the later variables, life, intelligence, technology, and especially L, remain almost as uncertain as they were in 1961. Atlas circled the letter L on his board. It would come back to haunt him soon enough. Now for the part Atlas actually cared about, rewriting the equation for his own universe. Not stars, boxes, not planets, universes. He renamed R star, the rate at which new universe maker boxes get switched on. Based on everything he'd charted since episode 11, that number wasn't small. He renamed N sub E how many boxes, on average, land in conditions gentle enough for something like Architect Boy's world. He renamed F sub P, the fraction of boxes that actually stabilize into a working universe at all. The biology variables became consciousness variables, the odds a box produces something that thinks and then builds. Atlas multiplied everything together, plugging in the honeycomb grid data from his own long nights of searching. The number that came out the other side made him sit back in his chair. Not 20, not 50, thousands. According to his own math, there should be thousands of other Atlas-like searchers out there, right now, doing exactly what he was doing. Atlas read the number 3 times, just to be sure he hadn't misplaced a decimal point. He hadn't. The math, cold and confident, said, "You are absolutely not alone." So then why, after 14 episodes of searching, had he found exactly one correlated signal? This is where real science ran into the exact same wall Atlas just had. In 2016, astronomers Adam Frank and Woodruff Sullivan proposed a twist on Drake's original question. Instead of asking how many civilizations exist right now, they asked a subtly different question. How many have ever existed across the entire history of the universe? Their answer, using extremely conservative numbers, was staggering. At least 10 billion trillion over cosmic history. 10 billion trillion. And yet, here on Earth, we've detected exactly 0 confirmed signals from any of them. The gap between should have existed constantly and we've found basically nothing isn't a small crack, it's a canyon. Atlas rubbed his temples. This was starting to feel very familiar. Not a new mystery, the same mystery, wearing new math. Fermi's paradox, the great filter, the dark forest, all of it circling the exact same gap. Maybe, Atlas thought, the problem was never really the first 6 variables. Maybe almost everyone gets past star formation, planets, habitability, even intelligence and technology. Maybe the entire mystery lives inside one single stubborn letter. L. Lel. How long a civilization keeps broadcasting before it goes quiet, one way or another. One NASA researcher, reflecting on Drake's legacy, put it bluntly. L was always the variable Drake worried about most. If L is long, thousands or millions of years, the galaxy should be humming with overlapping signals. If L is short, decades, centuries, most civilizations might flicker on and off faster than anyone could catch them. Atlas thought of the Great Filter file from episode 11. Maybe civilizations destroy themselves quickly, capping L low. He thought of the Dark Forest file from episode 12. Maybe civilizations choose to go quiet on purpose, capping L low a different way. 2 very different stories, the exact same mathematical fingerprint. A short, unlucky, or carefully hidden L would explain everything. Thousands of civilizations existing, almost none overlapping long enough to be heard. Atlas circled the letter L a second time, this time in violet ink, right next to where he'd circled the letter U back in episode 14. 2 circled letters, 2 different alphabets of mystery, somehow the same shape of question. If L really was the key, then signal 002 wasn't just a coincidence. It might be a narrow, fragile little window, a moment where 2 short-lived L's briefly overlapped. Atlas's paws hovered over the keyboard, a plan slowly forming. If he wanted to understand why that window opened for 6 seconds back in episode 11, he needed to trace signal 002 all the way back to its source. Not just its timestamp, its origin. Atlas gathered every file from the past 5 episodes onto one board. Fermi, Dark Forest, Goldilocks, Wow Signal, Drake. 5 separate nights of searching, one connected shape slowly coming into focus. He didn't have all the answers yet, but for the first time, he had the right question. Not is anyone out there, not even why so quiet, something sharper. Where exactly did Signal 002 actually come from? Atlas pulled up the coordinates buried in Signal 002's metadata, dormant since episode 14. Coordinates that, strangely, didn't point toward any star at all. They pointed toward something achingly familiar, a location disturbingly close to Architect Boy's own universe. Atlas's ears shot straight up. Every subscriber following this search has now watched all 7 Drake variables fall into place, except one. Next time, Atlas decided, he wouldn't just calculate the answer, he'd go find it. The season's biggest question was about to get its biggest answer. Thank you for counting the improbable with me tonight, architects. One file left to open, one journey left to take. See you next transmission.